usually I'd be at work now, but they'll be in various states of undress as they walk past this computer. So
okay.
and I'll have to go pretty close to 8:30 as well, because I've got to lecture at 9 to work.
Okay.
Sorry.
That's fine. No, I appreciate how valuable time is for everybody. Whether it's approaching the middle of the night or the first thing in the morning.
Hey Gary, I did an interview for BBC as well. It was only 3 minutes. I just sent it to you.
Yeah.
Unfortunately, it was the middle of the night. It doesn't look great, but it says good things.
Oh, smashing!
And I think it was part of the discussion we had last time, where I was getting really irritated with putting in grant funding applications and trying to get our work published. And they're things that we haven't really had problems with in the past. And so it's something to do with the way we're thinking about COVID that's really quite different. But anyway, when I got on there, they were asking me all these questions about the EU and UK stoush with AstraZeneca. And I was thinking, hang on, I didn't sign up for this interview.
Yes.
I did try and sort of bring it around to the leadership thing a bit and the systems. I didn't really use those words, but it was just fascinating that they think that they could get a pharmacologist from Australia to have something sane to say about EU, UK politics, apart from you boys need to sort your crap out.
Yeah, that's amazing. Okay.
But anyway, so I've sent it to you, and if you think it's okay, you could put it up in the collection.
Yeah.
But I think I got a lot of good feedback actually from people that work in the public service and some of the BPS people as well. So I think at some level it might be being more effective than my attempts, all the stuff that we're doing, Richard, which I think had a lot of impact in the research world, but changing the thinking. I don't really want to use the media because, as I said, these things just flummox you, but it kind of is. If I'm asked to do it, I'll definitely take up the offer now because it's of the feedback that I got on it. Yeah. Thanks.
Okay.
Well done, Jenny. It was terrific.
Yeah. Were you pleased with the way the interview went?
Oh, not really. No, I felt
I
felt unprepared and flummoxed with the questions.
Yeah.
But it's okay. I think there were some good things that were said. Yeah.
Yeah. What I'll do is I'll take a look at it and I'll check with you first. But what I might do is I might put it on the Facebook group for system science, and also for INCOSE, for the International Council on Systems Engineering, who really appreciate systems thinking and systems approaches. So that's an avenue to help get it out there.
No, that would be fine. I actually tweeted it anyway on Twitter yesterday. I had to think about it, and I thought, well, it's not about how I think it went. It's actually about the message and the fact that researchers are getting out there. So I'm happy to generate discussion. Yeah.
Okay.
Yeah. Thanks.
Right. Thanks. The only thing I've got really to say this time is, let's open it out to everybody. But what I've been doing is I've been taking all of the transcriptions of our discussions, and I've been starting to put them into that overview paper, and maybe some of the things will get taken out and moved elsewhere, and maybe we will elaborate on certain things. But I'm hoping that all of the results of our conversations so far will prove to be useful in some way. So I've done the first 2.5 sessions. I've still got a little bit to do. As ever, it's a case of finding the time and having the right mentality to do it. But I'm getting there gradually, and I think some people have been chipping in and have been starting to edit the material as well, and to start to make a little bit more sense of it. So hopefully that's going in the right direction. Is everybody aware of where that is?
Yeah. So, it looks really good. That's why I was wondering if you'd actually written a series for us, Gary, because as I'm reading it, I'm thinking this is all there. It's actually all in the document. I mean, obviously, like you say, it's got some things that you could flesh out a bit, but and I haven't worked on it yet, but I'm really grateful for what you've done there. It's a huge amount of work, but it's incredible reading. Thank you.
Oh, well, you're very welcome. I'm glad it's helpful. I mean, I'll just share my screen briefly just to show people, remind people where it is, if that's okay. So can you see my screen at the moment? Yeah. Is it coming through?
Yeah.
Yeah. Okay. So the transcripts are all in notes from our meetings, and you can listen to the recordings if you pull up these files. But in these Word files, you can also see the transcripts that have been done, through a converter. It's converted the speech into text, and then what I've been doing is I've been taking the text, and in the paper overview, I've been capturing it in COVID and the big picture. So this is all from the things that we've said, and the structure of the document is in accordance with the overall structure of the papers, but this would be, if you like, the backbone of the whole thing to give an introduction. So there's the abstract, and it's just words that we've said, and I've just sort of cleaned it up a little bit because the translator doesn't always do a perfect job. I've cut out some things that are around how did we get here, and that's my wife singing in the background. And then there's thinking and acting differently, data, information, misinformation, knowledge, intelligence, and wisdom. Host response to COVID and potential drug targets to prevent severe infection, which was, I think, that was the proposed title for the paper, which changed a little bit. Antiviral technologies, there's a little bit on there. Whole systems perspective modelling. There was quite a lot of stuff on this.
It's coming up with Arctic customers.
That's Kerry's mum. Then we have digital healthcare technologies, nothing in there yet. Societal change and practice. And I think that's it, yeah. And like I say, there's still 1.5 conversations to go in there, but I think there's a huge amount of useful material, yeah, as a starting point for the overall backbone. So, where are people at the moment?
You want us to just edit that, Gary?
Yeah, please. Yeah, just dive in there. I mean, you can comment on things. You've all got editor rights, so you can perhaps look for the words that you said, and if it's got it wrong, change it, elaborate it. Yeah, so there's no harm in everybody just diving in there and doing stuff. Yeah. And it does automatic configuration management. So, if the worst comes to the worst and someone presses the delete button, we can always roll it back.
And Gary, we take the sections that we were responsible for and use them as a starting point.
Yeah, that's a good idea. Yeah.
Yes, I must say I'm more focused on what one has to write.
Yeah.
To get the story across. Yeah.
Gary, it's Richard. In an exchange with Felix, it seems to me there's an area of human optics, which I think is really part of the difficulty that we all have in getting traction. And by that I mean it's very easy to dive to the molecular interactions and coming up with the vaccine and various other things. It's more difficult to stand back and say broadly what's going on, and it seems to me what's going on is the battle between simplicity and complexity, humans being incredibly complex, viruses being incredibly simple, and complexity is always associated with vulnerability, and simplicity exploits vulnerability, and so I mean that's what the COVID story is very much about, if you follow me.
I really like that concept, I must admit. In fact, I reckon that should be right up front.
Mm.
Then you can say, well, what's the issue here is not the biology of the virus. The issue here is the biology of the complex individual and how, this simple molecule can penetrate so far and do so much damage. And it's simply because the organism itself is amazingly complex.
Yeah.
And I would like that sort of as almost a lead off. It's a bit David Attenborough-ish, really.
Yeah.
And if you extend that a bit further, there are only 4 main proteins with the virus, 4 structural proteins with the virus. Any one of your cells, and you've got 40 trillion cells, but any one of them has between 80,000 and 400,000 different proteins. And so the degree of our complexity is astonishing. The degree of the virus's simplicity is awe-inspiring. And really, all the virus has done is sort out where the pivot is in terms of regulation and just pulled part of that pivot away. And then all the destruction is now done by our complexity.
Yeah. I really think, could you write a short sort of media type article on that theme? Because I think that part casts a completely new light with everybody focusing on vaccines and how, the mutant here and the mutant there and whatever. And nobody's thinking, right, here's this is very simple. The host is amazingly complex. Let's look at the host. Although there was some stuff came out last week in the media on repurposing drugs, but it did seem a bit hotchy-potchy.
No, I saw that, and it was, it seemed to me I couldn't see the systems behind the selection of those drugs.
Except for Meg Jardine and the repurposing of ARBs.
Oh, yeah. So the project that Richard and I were involved with, because ours didn't get funded and we heard that theirs was going, our group elected to join her. So that's actually got Richard's input into that study, and we're the hunter recruitment site for that study. We have ethics and everything. We just haven't had any patients. In fact, there's been no patients at all, I don't think, locally, maybe 1 or 2 in Australia, but the 200 that are being recruited have all come from India. So the study's now being extended to India and Brazil because we had no patients. But yeah, that certainly there are people of this group that are part of that big study. The problem I've got with that study is they went straight into a phase 3 randomized control study. And even though maybe their choice of drug is okay, we weren't really sure that the dose of the drug was clearly worked out and the timing either. So I'm just a little bit worried when you do a study with all of the pharmacology not sort of sorted out, that you can get a negative study, not because the drug doesn't work, but because the design of the study wasn't good. But because we were joining their study and they already had ethics and money, it was although we made those points, nobody listened. And we felt that it was better to be part of something than to be sitting out on our own with maybe the better idea, but actually no money or opportunity ever to do the study. So that's sort of how we got involved there. Yeah.
On that note, I sent an email around the other day arguing that if you look at the animal studies with ARBs, they're very successful. I mean, in acute respiratory distress syndrome, in SARS, there's absolutely no doubt that you change things. And you look at those doses, and I think for the mice studies, it was 25 milligrams intraperitoneally. And of course, anything we do with 25 milligrams of oral losartan, which I think is what the Jardine study has, is nothing compared to the doses that those mice got. And I think it's about time somebody sat down and said, these are animal experiments. This is the metabolism in the animal. This is the metabolism in the human. What dose do you really need to get the same result in a human that you get in a mouse?
Yeah, agree.
People just say, "Oh, humans are different," as though we still have a soul, or
So-
animals have a soul.
Yeah.
But
You
So
brought
I'd agree there, Eugenie, and I wonder, Gary, whether the second component of optics is around, in my mind, is around that area. And if you stand back and look at health research and look at the research in other disciplines, something is quite stark. And that is, if you're in meteorology, you can't do a randomized controlled trial. Not easily. And here in Adelaide last Sunday, a week before last Sunday, we were told that it was going to be probably 41, 42 Celsius, pretty hot, with a high likelihood of risk of fires. And what happened on Sunday, we hit 42 degrees and we had major fires. And I say, well, how did these people do that? Well, they did it based on years and years of observational data and spectacular modelling. And so meteorology has become a brilliant science in terms of its predictability. And not only out in days, but now moving out into months, and with climate change moving out into decades. And so observational studies have been the core. If you look at astronomy and radio astronomy, it's the same thing. It's pretty hard to do a randomized control study in the universe, but you can do a lot of observational studies. If you look at human health research, it's almost as if observational studies have been pushed to the background in preference to randomized control studies. And if you enter into a crisis like we have done with COVID, then it seems to me you need everything. You need observational studies lifted to the same scientific extent as other disciplines have, as well as your randomized control studies. You need both. And the amount of data that we've accumulated that could feed into observational studies globally must be huge. And it seems to me there's a major deficit. We just haven't we haven't moved in the same direction as other disciplines.
Well, so there's a way of thinking in situational awareness, and I can't remember you might remember the name of the person who invented this, Gary, but it's observe, orient, decide, and act. It was used originally in the military in training and developing combat pilots. And there's this progression of observe, orient, decide, and act actually relates to the development of our knowledge, in that the observation is related to information. Orientation is about the structuring of information into knowledge. And then the deciding relates to how to do, and then the act is the doing. Yeah. And I think that we're really missing a trick, converting our information into our orientation. You know, the structuring of our knowledge, so that based on that knowledge, we can then make meaningful decisions within that overall knowledge framework. And
it's absolutely brilliant.
Our science has failed us because it's missing that trick of converting observation into orientation.
And also the key thing in situations like this is getting that loop working faster, that feedback loop, so that you can learn faster. Yeah.
So there's definitely something wrong with the way we're applying our science in this particular context. And
that's
again,
a wonderful summary and map. That's just terrific.
I could come back to what Jeannie raised, the question about doses between mice and humans, etc. There's a whole sort of subdivision of pharmacokinetics called interspecies allometry, which scales what is the dose works in a mouse versus what should work in a human. And it's very simplest way of breaking it down. Most drugs which are broken down the liver, how much of the body is liver in a mouse versus a human is actually very important. I don't remember it exactly, but something like 5% of the mouse weight is the liver, but in humans it's only 1%.
Wow.
So the mouse has a much greater capacity for metabolizing drugs, getting rid of them, than does a human. And the guy who did all this work, Boxenbaum, who was originally at the Roche, he then moved off to the FDA and spent many years at the FDA helping them sort out this allometry discipline on looking at doses that worked in a laboratory animal versus what it can be in a human. And he's done some excellent reviews. I can put them down in a document for you. And it goes down, right up to whales and giraffes. It's not just weight. It's not just the surface area. A lot comes down to the actual liver. So what Eugenie raised, I think you need to consider it in terms of the liver activity of the different species.
So it's not a function of different SIPs, but more a function of the size of the liver. In other words, a mouse liver has inherently the same enzyme profile as a human liver.
Yeah, but they've got much more of it.
This
applies to all drugs which are broken the liver. Some things which are not broken down the liver, it doesn't necessarily work.
No.
He has come up with other ways of scaling them.
I'd love to see some of those reviews because it's bugging me. One of the things is that having been a basic scientist and used animal physiology as a basis to understanding human systems, and find that anybody in clinical medicine doesn't even look at that strategic basic science.
We'll just give you another simple analogy. The dose of pentobarbital to anesthetize a rat is something like 50 milligrams per kilogram, but the dose to hypnotize a human is only 50 milligrams, and that's into a 70 kilogram person. Yeah. So the dose in a human is only 1 milligram per kilogram, but it's 50 milligrams per kilogram in the rat or the mouse.
So on your basis, 25 milligrams of losartan orally should work orally, or should it be 25 milligrams intraperitoneally?
I think we thought
you assume the oral absorption is the same between them. Yeah.
Sorry to cut in, Bevan. I think, sorry, Eugenie, that we did do the dose response, some work using the FDA guidance of taking animal data into humans, because they actually do have a big table, and I think it's a 2003 FDA guidance, and they do have all the different species. And so you look at the species that the studies have been done in, and it tells you the scaling. And I didn't even look at the complicated formulae. I just put my numbers in. And then I looked at the results that came out, and it was somewhere around between about 50 to 100 of losartan. And that was actually consistent with the pharmacodynamic data. So that dose of 25 was never really going to do anything. It was really just to make sure you didn't cause hypotension when you gave patients the first dose.
Yeah, that's my feeling.
Yeah, but I think it was always intended that, certainly in the study that Richard and I were planning, that patients would start at that low dose, but would ramp up the dose relatively quickly as long as their potassium and blood pressure and a few other things are okay. But they didn't do that in the study that got funded. They just chose one dose. But they did say that you could use, so that they chose telmisartan, which I think you decided was a better drug anyway, Eugenie, because of its effect on PPAR. So it's probably better than losartan in the setting. But anyway, that's so I think this is all interesting, and I think that's where the FDA, Bevan, I think they probably had used your information to make their guidance in 2003, because it pretty much, there's a whole page on upscaling from a rat to a mouse to a dog with this, and even it doesn't matter which drug it is. the laws seem to hold quite well. So I definitely I've used those guidances when we were working out our dosing, but I don't think the study that got funded did that. Well, I know they didn't actually, because I asked them.
We got a totally different topic. We were looking at endometrial cancer cells and seeing whether ARBs would inhibit their proliferation and motility. And losartan had no effect. If anything, it was pro-proliferative, and telmisartan was very effective. And telmisartan was more effective than troglitazone. So if you had the combination of the AT1 blockade and the PPAR effect, you got a different effect compared to no effect with losartan, troglitazone having an effect. So I guess each chemical is another difference that people have got to take into consideration.
Eugenie, what you raised with animal and humans is absolutely on the money. I'll circulate a paper today where people did a very simple experiment, and that is they looked at glycemic index across something like 800 humans. And you can't do any simpler than that in terms of an experiment. In other words, look at blood glucose after a dose of carbohydrate. And if I recall correctly, the variation across 800 people was so huge that it was difficult to interpret anything. And so the difference in the animal studies and human studies is all experiments work, and what you see in an animal may well apply to a human, but not all humans. It may apply to a subset of humans and be incredibly relevant to that subset of humans, but effectively get diluted out by the non-responders in that setting. And that's really what worries me with a lot of those human comparisons where people say it didn't work. But if you dig into the data, and particularly if you look at scatter data and the rest of it, you can see that there are individuals that have responded, except they've just now been totally lost in the analysis. Yeah.
Well, I guess one of the big beefs I have are the papers coming out using looking at ACE inhibitors and their impact, and ARPs and their impact in the one cohort. The one that came out the other day that said, well, nothing much happens, which is a good thing. But if you're looking for a positive effect, they're probably acting at very different points in the pathway.
Absolutely. And if you look at that paper, and if you look closely at the responses of the ARBs, they were different than the ACE inhibitors, but more particularly, there was a component, and fairly large component of the ARBs that were operating in precisely the opposite direction. In other words, they were protective. And so, but they get lost in the stats where people just simply mean average and do confidence intervals. The analysis that should be always conducted in my mind is responder versus non-responder. And within any population, that's critical, particularly in COVID, for example, because you've got this temporal issue where interfering and helping with the angiotensin system may be really important early, but once the fire is away, it may be less effective. And so depending where you are on that scale, response versus non-response is absolutely critical.
Yeah. There's a similar, and again, I think this ties into Bevan's long-term perspective as well, along COVID. We know clinically that angiotensin receptor blockers have no real benefits at the end stage of sepsis. You know, when you're going into the severe sepsis and septic shock, it might well be that ARBs provide some benefit before the loss of, I don't know, vascular integrity. Before that event, it may be that ARBs provide a benefit, but during the septic shock, the multiple organ dysfunction, it's just too far gone. ARBs aren't having any positive effect there at all. So the phase and the situational context is always so important, because as you say, Richard, this is a highly complex system and situation, and things change dramatically over time as you move from one phase to the next.
The other thing that's associated with that change, Gary, is a reinterpretation of what a drug does. Now, if you take the area of antihypertensive generally, the dominance was really around cardiovascular mechanisms. The notion that there's something else going on has been only quite recent, maybe the last 10 years, 15 years, that in actual fact, when someone is prescribed an agent that interferes with ACE or ARBs, the issue of mechanics and cardiovascular mechanics is less important than the issue of dampening down inflammation, yes, which is driving remodeling of the blood vessels. Yeah. I mean, that's the game. Yeah. But we haven't moved on from in thinking. People haven't moved on to say, when you give an antihypertensive, you're actually giving a very sophisticated anti-inflammatory for the cardiovascular system. And so part of it's optics all the way down the track. And if you look at the susceptibility to COVID, the virus is really locked onto a complex system. That complex system's vulnerability is widespread inflammation throughout life. And the trigger point is the renin-angiotensin system. Yeah. And it's almost irrelevant whether they're cardiovascular drugs that interfere with RAS. It doesn't really matter. It's dampening down, it's correcting the dysregulation that's associated with the inflammatory response.
Yeah. The way I see things is the cardiovascular effects in terms of blood pressure and salt retention are just one small part of its wider purpose, which is managing our body's integrity. Managing our body's response to injury and wounding, to stress. Yeah,
exactly.
Activation of the AT1 receptor is the pivotal response to stress at the cellular level. Whether it's hypoxic, glycemic, oxidative, physical. It is the, what's the word? I can't remember the term, but it's basically, the key mechanism for recognizing stress and responding to stress at the cellular level. And, when that stress is unresolved, you get chronic inflammation. Yeah. Exactly. Cardiovascular disease is an inflammatory disease.
It is. And so it's as if we're looking at a language now with a dictionary that we haven't moved on from the 1800s. And we're saying, why are we confused?
Oh, hang on, 1800s is a bit incorrect because Tiggerstedt and Goodman didn't do their paper collating, and that was written. And took a few years later for it to be.
All right, a few years later.
To produce angiotensin.
Yeah. But Virchow had it absolutely right when he said that cancer is the wound that never heals. Yeah. And the reason it doesn't heal is because it's of unresolved stress. The growing tumor in its environment and the activation of the renin-angiotensin system. That's what's going on.
But very early on, not once the tumor is established.
But I think as the tumor is established and it continues to grow, it is exerting a stress on its microenvironment.
Yeah, but in a tumor, you've got a neoangiogenesis, and that side of it is where the renin-angiotensin system is pretty important, I reckon.
Yeah. So we've got 15 minutes left. I think again the discussion so far has been really helpful. There's been a lot of stuff that I will gather and start to put into the papers. But I want to give everybody the chance to say anything that's on their mind that they haven't had a chance to yet. I know that Kirsty and Kerry have been listening a lot and wrapping their minds around this stuff. So let's start off with Kirsty and then Kerry in terms of anything that's on their mind at the moment.
Oh, I am on. I didn't know if I was on mute then. No, I've got nothing really to add. I think the conversation's great. And I, again, apologise for that I haven't done much so far with the documents, but I'll get onto that in the next couple of weeks. I don't really have anything to add today though, no.
Okay, thank you. Kerry, how are you feeling at the moment? Because obviously there's been a lot of talk of biology and molecular science.
Yeah.
All
sorts of things that I have
social
no
person.
clue about. Yeah, well, it's interesting, but I don't necessarily understand it. To be able to understand something like this, I have to be able to map it out as a system and understand the interactions. What I started doing, and I've not done it by going to look to see what other people have done, I started to do it for myself, is to map out my own understanding of the bigger picture in terms of what's actually going on as a system dynamics model. Because that's the way I understand things. It's not quite finished yet, but if we're meeting again next week, hopefully I should have something that I could show you about that as well.
Yeah, so we'll do this in a couple of weeks. I mean, there's nothing to stop you from showing it briefly for a couple of minutes now, Kerry, if you'd like to, just to give us a sense of where you're going with it.
No, it's not. I did it on paper. If I showed you it on paper, and I've got to put it into Vensim, you see.
Okay.
So you wouldn't be able to. It would be completely incomprehensible because it's my scribbles. And
looks like there's quite a few scribbles and pieces of paper there.
Yeah, as always.
Okay.
As always.
Okay.
Yeah.
We can look forward to a model that you can show us in a couple of weeks' time.
Yes.
Yeah. And it's a
indeed.
shame.
And I'll have a look at, like Kirsty, I've not really had time to have a look at all the documents, but I will.
Yeah.
I'm not sure what I'll be able to contribute on the discussions that we've been having today. It's not my forte, but I can have a look and see whether it makes sense to me. I'm not sure whether I'm the target audience.
I mean, the thing is, so systems thinking, and so the biology is not my background either. Yeah, I got into this by mistake, and I haven't been able to escape. Yeah. So the beauty of this topic is its complexity. Yeah.
Yes.
It's massive complexity. It is a treasure trove for systems thinking. And by engaging in a domain like this, it absolutely forces you, you have to apply systems thinking in order to get a comprehension of it. So I've learned a lot about systems thinking by doing this, by then reflecting on my systems thinking. But this was absolutely not my domain at all.
Yeah.
So
I always think that the really interesting applications of systems thinking are in biology, so with a human system, or out in the big wide world in terms of geography and climate change, the really big systems outside of ourselves. I find both ends are really interesting.
Yeah.
Actually, there is on the website a drawing from a guy called Guyton, who was the preeminent cardiovascular physiologist in America. And he applied computer modeling, which is really systems, to the cardiovascular system. And I think I sent that, and it's there I saw it there in the shopping list of things that are in the Gary's drive. So have a look at that and see just how complicated, looking at a simple system, looking at what was a simple system in those days, namely the cardiovascular system, nothing to do with vascular integrity, just going function. And then you build on top of that all the local vascular interactions. And you take a system like that, it just becomes incredibly complicated. And at the other end, of course, you've got the brain, which everyone has forgotten about in terms of cardiovascular control.
So if I could just pick up on that, Kerry, if you look at everyone sitting around this electronic table now, I don't think anyone here is monitoring their own filtration rates in their kidney or their metabolism in the liver or their heart rate or their peristalsis. And you've got to say why? Because it's a devolved automated process. And and that frees up the brain to do things like what we're doing now. And so if you then look at that devolved process and say, what's the commonality? Then it's a systems issue, because what you see is actually a simplicity in that devolved process. And the simplicity simply is push-pull. Look at angiotensin. You've got angiotensin doing one thing in one direction and another set of receptors doing precisely the opposite. And it's that balanced regulated process that's repeated over and over and over. And it's that which gives you the automation. And it doesn't matter whether you look at the way the nervous system is set up, for example, the autonomic nervous system, with sympathetic and parasympathetic pushing in one direction and monitoring in the other. But it's complex in terms of its scale, but in terms of its principle, it's more or less a single principle, and that it's a fulcrum balance that's repeated over and over and over. And what we've got with COVID is a very clever virus that's gone into to find out which fulcrum can you pull the pin under and watch the whole thing collapse. And so it is, as Gary said, it truly is a systems analysis entity that we're dealing with.
Yeah, one thing I was just going to add on that, because I think you're spot on, Richard, and it was something that you add in your slides, was the incredible destruction thinking does on a system. And that's probably the problem in COVID. Like, I think we do know a lot about the biology and how these systems in the body work, but then we've got this brain that does feeling and emotion and perception and politics and, attempts at climbing career ladders, and all of that sort of subverts the systems thinking. And I kind of think that's where we get into trouble. And in the workplace, when systems are really important, like, this is your area, Gary, but also in some parts of health, we have a very regulated system about how people behave and checks and balances and protocols and things like that. But then what happens, I think, in practice is that people get emotional about something, or they're tired, and then they just override the protocol or forget it. And I kind of think that might have happened with COVID, that if we actually all stopped and thought about it, it's really clear what's going on with the virus and the sort of research trajectory we should have had and should have going forward. But somehow there's all these other things that are usurping our systems thinking. And I think that's not my area of expertise, but I'm very interested in it because I see it in a complex organisational role in terms of behaviour in the organisations I work in. And you can really make quite a mess of things quite quickly, even though you've got technical experts or systems thinkers within them. I think that might come out in some of the, I think you've already got it there somewhere, Gary, in your documents. And I think it might have been a bit the section that you and I were supposed to write, Richard. But I don't think it's only really just come to me thinking over the last few days that it's this human behaviour that's really mucked everything up.
Yes.
Funny.
We've had a lot of practice, Jenny.
Yeah.
Yeah, we're still a relatively young species, aren't we? Really.
Yeah. If you read David Attenborough's book on his latest book, it's just absolutely. It does the same thing. It talks about the Earth as a system, and everything within it are systems. Like, I never even knew that whales were important because they dive deep and bring up the nutrients from the bottom of the ocean when they dive, and so you've got the whale bump and things like this. And you go, gosh, everything is interrelated to everything else and works sort of on feedback loops.
Now, I wonder if I could just add to that, Eugenie, when you look at the renin-angiotensin system with its push-pull mechanisms, ATR1 going in one direction and ACE2 driving things in a different direction, and in the sympathetics, alpha receptors going in one direction and beta in the other, I've often wondered whether biology discovered digitization well before we did. Because when you think about it, it's a digital process at its core, and maybe if we rethink along those lines, then and incorporate that into a systems process. Because Gary, I think I'm right by saying digitisation has probably been absolutely fantastic for systems analysis and systems thinking and systems processes. But I think biology got there a long time ago.
Yeah, well, it's basic physics as well. You get down to the quantum level and it's all noughts and ones. In fact, the universe is probably just information. We only perceive it as matter and energy.
No, it's 42.
Yes, exactly, yes. Yeah. Well, what coming back to the social aspect you mentioned, Jennifer. You remember I showed you some slides last time on this stuff, yeah. So powers, problems, pathways to enable the powers, yeah. So this is our emerging framework for system science. What I didn't realise, but this was brought to my attention last week. I don't know if you've heard of the Tao Te Ching, which is Chinese philosophy, and the Tao, which is the way, and within that book, which is second only to the Bible in terms of its translations, it talks about essentially 81 different principles for living within the Tao, and those 81 principles actually map into this overall matrix. But when I showed this to a colleague at work, he said, this is all well and good, but you also need to think about the negative. So the utilization of power to disassociate systems and degrade systems. Yeah. So this is what Kerry and I and others have been working on. So what we've been looking at, and we'll just focus on the political, yeah. So when we talk about the political, we're talking about the engagement. I would say the engagement with stakeholders generally. We don't just have to think of this as politics, but of course, you know, you can see it. So here we have political in the center, and the four problems, systemic issues around the political are taking the wrong action, lack of information, knowledge, and appreciation, no vision of the future situation, and not seeing the connection and flow of causality. And then we look at the political and essentially the abuse of powers. We have reluctance to change, to retain the establishment, the manipulation of relationships, i.e. to blame the other, a subgroup or an alien, taking decisions that benefit the parts and not the whole, which is corruption. And here we have manipulation of information, hiding and downplaying the consequences, which causes this issue here. So this is something that we're working on at the moment, and I think again this has the potential to be quite powerful, because, you know, for those of you who have perhaps a more chemistry background, you can see, and you know, because I'm a chemist, you can see that essentially what you might have is you might have what's the word? You have potentially an equilibrium in terms of pathways, yeah. And yeah, if we look at each of these situations, what can we do to essentially restore balance where balance is needed? Yeah, you get what I'm saying? Yeah, Le Chatelier's principle and all of that. Yeah.
Yeah, I understand that.
Yeah, I do too. Yeah.
I mean, it's sort of, yeah. Anyway, I'm sure that's part of it. Someone sent me something from The Guardian today about the political, and I was just reflecting on that as you were talking, because all of these things like reluctance to change, manipulation of the information, it was about your leader, Boris.
Oh yeah.
He actually gets like a full house on all of those points.
Yes.
I just sent it to you, but it was sent to me by someone else. Yeah, so that's another, it's kind of almost the unspeakable. I mean, that's coming back to that BBC thing. It's the stuff that we haven't really wanted to get involved in. It's dirty, the politics and
Yeah.
the organisational culture and these sort of things. But I actually, and I think that's when I wrote to Eugenia, not to the whole group, but just thinking about another grant or another, it just fills me with dread, because I think we could do all this stuff, but nobody really cares and no one's interested, and there's no money for that. And the real problems with this are actually in the very hard basket in the political and other places, but we don't have the skills or the connections to be able to manipulate that. I'm not saying we shouldn't try. I think I just feel overwhelmed with there's a lot of time that's going nowhere.
Yeah.
Gary, if I could go back to your chemistry and the equilibrium, and I agree completely that, you know, you could put affinity constants and equilibrium through the whole system, and it's a good way of looking at it. There's no doubt. But it seems to me that this process can describe two states. One is a steady state where you don't have a pandemic or you don't have major issues, and all this applies in various ways. And really the gravity of the issues, it's probably not that high. However, when you've got a crisis situation and a pandemic, it seems to me there's a different emphasis then across this whole pattern.
Yeah.
But Richard,
Yeah.
you don't need to apply this to a pandemic. Apply it to climate change.
Or climate change.
Oh, yeah,
exactly.
yeah.
This is chronically existing, not the other one.
Yeah. In other words, I think that I couldn't agree more, Eugenia. I think the temptation is to apply the same processes that we get by with in a steady state to a crisis.
Yeah.
Where history is replete with examples of where success occurs is you change the paradigm around in a crisis situation.
Yeah. Yeah.
Bye.
Everyone.
Okay. Yes, it's past, and I'm sure many people have to take children to school and stuff like that.
Yeah, I'm going to have to head off too. Sorry.
Yeah, no, that's fine.
Right.
So we've used the hour, and I think the conversation has been great. I think there's been a lot of stuff that we've talked about that we can take into our papers. So thanks again. See you in a couple of weeks. Don't be afraid to get into the papers and start to do stuff. As I said to Jennifer, just do what you can, yeah, and we'll get there together. Okay. So thanks a lot, and see you in a couple of weeks.
Thanks, Gary. Thanks, everyone.
Thanks.
Bye.
Bye-bye.
Bye.
Bye.